line R1, we're taking a look at learning task 2, which is going to be dealing with the installation of discharge lighting. Let's go over to our very first picture. Surprise! No pretty pictures. This one is all going to go and be text-based and is going to be dealing with a lot of our Canadian electrical code, because that's really what's governing how we go and put in our discharge lighting circuits. Discharge lighting circuits are going to be different than incandescent lighting circuits that you would have covered over inside of first year. Incandescent lighting had to go and have special types of switches. They had to go and be T-rated, that they were going to be, so that they were going to be tungsten rated. And other than that, there wasn't a lot of crazy stuff that was happening when it came to my control of, incandescent lights. Induction lights, or discharge lightings, as we refer to it as, is going to be different because we have got transformers, we have got inrushes, and we have got collapsing fields around those ballasts. Those ballasts are transformers that are going to go and happen inside of it. So let's go through some Canadian electrical code as it pertains to section 30 over here. Talking about the very first part, they talk about switches that we can go and utilize with our our lights that we are going to go and have. And I'm just going to roll up a little bit here just to my circuit supports and installation, location, protection, bonding, etc. We'll go all the way up to the very top over here. When it comes to discharge lighting, we have to go and have branch circuit voltage that is not going to go and exceed that 150 volts to ground anytime that we are going to be inside of a dwelling unit. Whether that's going to be for any of my discharge lighting or whether that's going to be my incandescent. So if you're working inside of a commercial or semi-commercial type of installation like a condo, you sometimes have got higher values of voltage that you will utilize inside of hallways and places like that that are maintained by trained maintenance personnel. But inside of your units, you're going to be limiting those things to 150 volts. Outside of the dwelling units, inside of hallways or anything like that, we can go to a different nominal system voltage. It's very common that we're going to go to a higher value of voltage because higher volts means lower amps for the same amount of watts. And looking through all of these discharge lighting, the fluorescents, we saw that all of our tubes are going to be rated inside of watts. So we go to a higher value of voltage. This is very dangerous to go to this 347. You've probably heard people talk about 347 before and its dangers. The big danger with it is that it is high enough that it's not going to allow you to let go so you get frozen to it, but low enough that you don't instantly burn off. Instead, you just stay on there and you slowly cook out. It's a terrifying feeling. I've been stuck on a line before and it sucks. It feels like drowning and you can feel the burn at the same time. So be careful anytime that you are not inside of a dwelling unit. Inside of a dwelling unit, you're going to be fine for, excuse me, you're going to, sorry, I'm just choking here on my coffee. You're going to be fine for your voltage rating. But outside, even in hallways of condo units and the like, you need to be aware that there's going to be higher values of voltage. Inside of a dwelling unit, we're going to be limited to 50 amps as well. Outside of a dwelling unit, we are going to be 50 amps if it's going to be high voltage, or 20 amps as long as it's not going to be over top of 347. And then they give us a whole pile of other places where we can go higher. 40 amps in other than dwelling units where the load is from, Luminaires or HID luminaires that we are going to go and have, or luminaires provided with an integral overcurrent device. Most of that's not going to apply to our fluorescents. All right, let's go down a little bit further into location. We don't need to worry about that. That's stuff that you should have already covered. Installation. This is just going to go and talk about all luminaires. The way that we need to support them. We have to go and cover the outlet boxes, the circuit connections, etc. And then this one over here is a big one to us, 3308. Every luminaire shall be installed so that connections between the luminaire insulated conductors and the branch circuit insulated conductors can be inspected without disconnecting any part of the wiring unless the connection employs a plug and receptacle. So you need to be able to go and open stuff up without having to go and apply, take power apart. If you take a look at troffers, you have got that plate on the top that you can go and open up, or you can pull down the bottom part of the fixture and you can remove the ballast cover. We're supposed to be able to inspect without necessarily having to separate any wires, just because of the values of voltages that we are going to have. There's also this one here, 3308, which talks about branch circuit insulated conductors within 75 millimeters of a ballast. Within the ballast compartment shall have a maximum allowable insulated conductor temperature of not less than 90 degrees Celsius. So anytime that we take a conductor into there, if it's within 75 millimeters, that's going to be 3 inches. It has to be not less than 90-degree rated wire. Subrule 4 was recently added into the Canadian Electrical Code. I think this was 2012 that we had added this one in, and you should be familiar with what it's requiring. It's talking about anytime that we've got connection of branch circuit insulated conductors that exceed 152 volts to ground, so we're talking about a 347 or anything like that, to the conductors of each luminaire utilizing double-ended lamps connected to a ballast or driver shall be made by means of mated separable conductor connectors that will safely disconnect all conductors of the luminaire from branch circuit conductors simultaneously when the conductor connectors are separate. They're talking about those little orange ballast disconnects that you get inside of a fixture. Every new fixture that you buy these days usually has those inside. Older fixtures, when you are reading, you're supposed to be placing these things in there. It says the connection of branch circuit insulated conductors exceeding 150 volts to ground. Meaning that if you are less than 150, so 120 volts, you don't need to necessarily have them on there. So low voltage is not required, but anything that's 347 and higher is required so that you're going to be able to go and unplug that to do the ballast change. Luminaires as a raceway is another common thing that happens. Luminaires as a raceway are going to be where we end-to-end mount long, like usually 8-foot, luminaires. They could be LED, they could be fluorescent. And then what we'll do is we will go and run wiring through from one to the next, to the next, to the next. And when we do that, we have to be very cognizant of the heat that is going to be generated. It says ballast located within the luminaires shall be deemed to be sources of heat. So obviously they're going to be hot. And the conductors supplying the luminaires shall have a voltage rating not less than 600 volts. Note that this is a voltage rating. I'm trying just to highlight only that one. A voltage rating. You need to be aware of what your conductors themselves are. A Lumex is rated for 300 volts, which means that underneath subrule 2, the Lumex would be disallowed. Subrule B of this one says an insulation temperature rating not less than 90 degrees, so we need to have 90-degree conductors rated for 600 volts. And then C, we have a type selected in part Rule 12.102.3, which kicks you over to table number 19, and table D1, as being suitable for use inside of a raceway. So it has to be the proper type for inside of a raceway. But then at the very bottom, they do give us a pass on non-metallic sheath cable shall be permitted to be used for supplying the luminaires, provided that it has a temperature rating of at least 90 degrees Celsius. You are allowed to go and use NMD 90 inside of these. Although the previous one said it had to be 600 volt rating, they realized that, there's miles of this stuff that is in ceilings all over the place that we can't, control this, so we're just going to go and allow it rather than having to fail everybody out. So if you are working inside of a Lumex installation, you can use Lumex to go from conductor to conductor. That being said, if you're going to be working inside of a commercial installation where you're already working with BX, that is going to be 600 volts. They're going to expect you to use those BX conductors. They don't expect you to enter with, a chunk of BX and then use a bunch of stripped Lumex to go from ballast to ballast. That would be improper application of the rule. If you've already got 600 volt conductors, utilize those 600 volt conductors that you have. Okay, we're going to skip down past some of that. Low luminaires, these are just installation things. Damp locations near grounded metal. Wiring of lighting equipment, ceiling outlet boxes. Once again, general stuff. You should have covered all of this stuff there before. We'll just go up to this one here a second. Branch circuit conductors having insulation suitable for 90 degrees shall be used for connection of ceiling outlet boxes on which a luminaire is mounted. So if you've got a flush octagon box and you are going to go and place your fluorescent fixture over top of it, you have to go and have 90-degree rated conductors, except for boxes in wet locations where type NMW and NMWU cables are going to be allowed. Other than that, we have to limit them to 90 degrees. And then it says, for the purposes of compliance with this rule, the ampacity of 90-degree insulated conductors shall be limited to the ampacity of 60-degree insulated conductors. What they're telling us is that any time that I've got a ceiling outlet box, this over here, I need to go and take my AWG size. If I'm trying to size conductors, I need to take that out of the 60-degree column. And the reason for that is they don't want to flow more current through there than what would result in them heating to more than 60 degrees, because there's already so much heat associated with all of my lighting. Okay, we're going to go down from there. We're going to go down from there. Tap conductors. You're allowed to do tap conductors if you're doing continuous row mounts. If you've got a 20 amp continuous row that you're going to have, so you got a 20 amp fixture. This obviously could not be in a dwelling unit, but you're allowed to be 20 amps outside of a dwelling unit. You could have a 20 amp circuit that's going to be fed with number 12s, and then where you tap down into that row of continuous end-to-end mounted fluorescents, you are allowed to go and drop down to a smaller gauge of 14 AWG, not 16, not 18, but down to a 14, provided that you don't go more than 7.5 meters in length, and provided that all the lamps that are going to be connected to it, or the ballast connected to it, do not exceed the current value that would be off of it. That would be where this, you've got your ceiling outlet box, you're coming into there with number 12, and then you're allowed to tap down into 14 and go through each of those fixtures, but you have to go and add up all of those amps and make sure that they're not going to be above the rating of a number 14 out of the 60 degree column for that one. Okay, let's stuff about where we have to locate them. We're going to go past that one. This is going to be lamp holders. This is where we are going to go and take a look. Electric discharge systems operating at 1,000 volts or less. We're talking about discharge lighting with fluorescence. So that's what this section is going to be. Just do discharge lighting, highlight that inside of there. We are going to go and be 1,000 volts or less. So we're going to go and skip past some of this stuff over here. We're going to move down to this one. Where equipment has an open circuit voltage of more than 300 volts, it shall not be installed inside of a dwelling unit unless the equipment is designed so that no live parts are exposed during the insertion or removal of lamps. What they are talking about inside of this one is not the voltage to ground that we are feeding it, because we're talking about a dwelling unit. That's still going to be limited to 150 volts as we saw before. What they're talking about, oh, that's the wrong one there, is they're talking about the end-to-end values that we are going to go and have. So if I take a look at this one over here, going back into the actual code rule over here, no more than 300 volts as an open circuit voltage. They're talking about the ballast and the lamps. This is what we have. Eliminate that there. Draw up a fixture. So we got the fixture itself. We're going to go and have the tombstones on the end that we are going to go and connect our lights into. We are going to go and have the ballast that's going to be inside of here. The ballast has to be fed with no more than 150 volts to ground. So 120 volts we are going to go and feed into the ballast. Then the ballast itself is going to go and have its conductors that are going to go out to either end over here. That open circuit voltage, the OCV, across from there to there cannot be more than 300 volts. Once again, lamp replacements are something that most homeowners think that they're going to be capable of. And so we have to make sure that they're going to be able to do so safely. It doesn't prohibit us from having more than 300 volts across there. What it prohibits us from is having that unrestricted. And it says that we're not allowed to unless the equipment is designed so that no live parts are exposed during the insertion or removal of lamps. Remember when we were talking about those slimline lamps before and how they have got that spring-loaded end cap? That's what would allow you to go and have slim lines, which are going to be up into the hundreds and thousands of volts across those tubes inside of a residence, because that little cutout switch will prevent that from being energized whenever they're inserting or removing. Auxiliary equipment, any other auxiliary equipment has to be within the luminaire, suitable for it, control, etc. We're going to go down to this one here, 3710. So control of a fluorescent, the luminaires and lamp installation shall be controlled by a switch, circuit breaker, or contactor. That makes sense. We need to have something that we can switch it on and off. Where a switch is used, it shall be marked for the control of lighting systems operating at 1,000 volts or less, and have a current rating not less than twice the current rating of the lamps or transformers. In other words, if your light fixture has got a 8 amp draw, you need to have a 16 amp switch that you're going to be able to go and have. It has to make and break onto a ballast. That ballast is going to be an inductor, which means it's going to go and have a collapsing field, and it's also going to have a little bit of inrush that's going to happen just off of the parasitic capacitance that's inside of it. So they make us go to a higher value of current. This is different than an incandescent. So it has to be marked for it. It has to have a current rating that's going to be at least twice, or it has to be a manually operated general use AC switch complying with 14510. This is where we get our regular light switches that we're allowed to use them off of a fluorescent fixture. That's underneath that rule 14510. They give you a bunch of installations where that's acceptable. Or it can be a generally manually operated general use 347 volt AC switch that complies with rule 14512. We're going to go there in a second, okay? The other way that we're allowed to go and control them is a circuit breaker, which has to comply with the requirements of rule 14104. And then it has to be marked as SWD, switching duty. Highlight that section right over there, shall be marked SWD. There's a big difference between something that can just carry the current through versus something that can be continuously operated off and on. So if the breaker is going to be used as a switch, I don't recommend it. But if it is, it needs to be SWD. Where a contactor is used, it shall be marked for the control of electric lighting systems, like I say inductive loads, and it has to have a current rating of not less than twice the current rating of the lamps or transformers. You can try to get away with not following these, suggestions, but you will end up burning out equipment. Make sure that you are going to go and have these things at least twice that are going to be inside there. All right, we'll just go to those rules there real quick. 14510 and 14512. It just says that manually operated general use switches intended for AC systems shall have an ampere rating not less than the current rating of the load which they are installed, supplying tungsten filament lamps, non-inductive loads or inductive loads, and not less than 75% power factor lag. If you have got a fluorescent that is less than 75%, it's an uncorrected fluorescent, you would not be allowed to use a general use AC switch. Same with these ones over here, very similar. Once again, it's that power factor that they want us to go in to watch out for. All right, let's go back into our manual, or into our binders over here. In the binders, they talk about most of those things that we've referred to. They do go back a little bit up to occupancy sensors, daylight harvesting, and load shedding. Yes, we can go and switch stuff off. They do say that we can dim. We can't really dim with most fluorescents. We're going to skip past that. That should never have been written in the module, but most fluorescents are not dimmer compatible. You burn them out. We will go and load shed at times if we hit those peak limits. We talked about this during the HVAC section, that if you go past either the service limit, you're going to burn out your service, or if you go past what BC Hydro wants you to take at any given time, you're going to get penalized for that. So we will have some stuff that's going to go and switch those things off. Ballast location is also going to be a thing to watch for their installation. We are allowed to go and have our ballast remote. You'll see this commonly inside of like ornamental type of installations. Think about any place that has got like huge vaulted ceilings or, a massive lobby or something like that. And then you're going to go and get these HID fixtures or fluorescent fixtures that oftentimes are going to drop down. They're going to be what we refer to as like UFO type of fixtures. They're kind of these rounded ones like that. We oftentimes don't want to have the ballast in there because it's supposed to be, like a nice space. You don't want to have ballast on, and the ballast is a big ugly box above it. What you're allowed to do is you are allowed to go and run your circuit conductors back to a remote mounted set of ballast. Common places for this are going to be places that are going to be architectural ones where they want to show it off as a feature. It's a fancy light inside of a fancy ceiling that they want people to, ooh and ah over. The other place that we see it is commonly inside of gymnasiums. Gymnasiums are going to be, well, obviously rough surface, basketballs and stuff like that. They carry a phenomenal amount of weight. So if you got a ballast up there, there's a greater chance that if something comes down, it's going to come down hard and do some damage to, people. And it's also going to be easier to knock off the ceiling because of the amount of weight. So we'll mount those remote. And then the last place that we commonly see it is going to be inside of like churches or places of worship where they want to go and have a quiet environment. So they want to remove that ballast noise from it. So any one of those installations are going to go and require that remote mounted ballast. You are going to usually have to go to a higher value of voltage. Usually it's going to be 1,000 volts rated conductors that you're going to have to go from, location to location because it's a much more intense voltage that we'll use for striking a lot of our fluorescents. There's also going to be temperature limitations that go along with it, and distances. You have to go and have, distance correction that needs to take place. Most fixtures, if the ballast is already mounted to it, don't try to separate and do it yourself. These are special built ones, and you would follow the manufacturer specs for the gauge of wire and how far you're going to be moving those around. They do talk a little bit in this section over here about merc vape and metal halide, because that's a common thing that we are going to go on to remotely mount. Less common with standard fluorescent. But some of those ones inside of there, the merc vape and the metal halide, don't have a high striking voltage, whereas this other one we're going to learn about, the high pressure sodium, not the low pressure one that we looked at, but the high pressure sodium, is going to go and have a ridiculously high value of voltage, and so it needs to go and have specialized conductors because it also gets more voltage drop. Controls for HID fixtures. This is going to be something that, once again, is going to be a little premature for the fluorescent, but we'll cover it because we're in here right now. HID fixtures are going to be our ballasted lights, and if you've ever worked around those big ballasted metal halide or anything, you know that if you shut them off, that they take a long time to go and restrike. Because they take a long time to go and restrike, we need to have some other method to ensure that there's light if and when we need it. There's a couple things to talk about inside of this section. One of them is going to be those irises. They call them barn doors inside of here, but if you go to any place that is going to need to control the lighting through HID, what they will often have is they're going to go and have a set of shutters that go over top that they can blank out some of the light, or they can go and allow more light back through. The light itself always stays burning inside of here. They're going to require additional ventilation out the top as well. And then the irises are just going to block whether that light is actually getting down to wherever you're trying to spotlight it on. The other thing that you will have is you will sometimes go and have a built-in tungsten light. Tungsten halogen lights are a high temperature type of light, so they can take that environment. They're also an incandescent, so they're going to be able to switch on almost instantly. So if I place one of those inside of here, if I would get a power failure, the instant that that power comes back on, this tungsten light would be able to operate. And the tungsten light is tied to a little photocell that's also inside of that fixture. And that photocell is just going to be watching until the main bulb restrikes. If it takes the main bulb, 10 minutes to go and restrike, it'll keep burning this halogen, providing just enough safety lighting for people to, get out of places, etc. The last one that they talk about is going to be a high-low ballast. Very uncommon. I would not expect to go and see these, but they do have some of these that have been manufactured in the past. We probably won't see a lot more manufactured in the future with LED, because LED we are actually able to do a lot of dimming. But the high-low ballasts are going to give you the ability to have like two separate values of voltage and current that you can run off of them. All right, that is learning task number 2. We are on to the actual HID lamps next, and some of what we just covered now will make a bit more sense after we have talked about those as well.